I'm Garrett Gailey, and this is my presentation on my final research. So my topic was technical advancements in land surveying. Land surveying is the technique, profession, art, and science of determining the terrestrial or three-dimensional positions of points and the distance and angles between them. A land surveying professional is called a land surveyor. These points are usually on the surface of the earth, and they're often used to establish maps and boundaries for ownership, locations, such as the design positions of structural components for construction or the surface location of subsurface features or other purposes required by government or civil law, such as property. So if a piece of land has to be sold or a boundary has to be moved, the land's got to be split up into different pieces, any of that, the land has to be surveyed, just so you know your boundaries and there won't be any confusion. Surveying technologies. Surveying was first conducted by a surveyor with a compass and a tape measure. It was just a metal string pretty much, and it was very basic and took a long time to do. As surveying evolved, theodolites were invented and made the surveying process much faster. Theodolite is a telescopic instrument that allows you to measure the distance. Pretty much just a telescope with crosshairs on it, and you get your instrument level and you shoot distances onto other known targets, and it just tells you, you can use that to calculate the distance. Currently, surveyors use total stations, which are a type of theodolite. They're more advanced than theodolite. Total stations shoot a laser at your target and calculate the distance, horizontal and vertical angles. They also store the points, so it's just a lot easier when you go in to make a map out what you shot. Robotic total stations are new improvements to surveying. They allow the surveyor to do the same process just more efficiently. It allows, if you don't have a robotic total station, it takes about 2 or 3 people to run a crew. With a robotic total station, you can do it with one person. You set up the instrument and you run the instrument from where you're shooting at. Accuracy of surveying equipment. The accuracy of the survey depends mostly on the surveyor. The setup is the most important part of surveying. The total station must be perfectly level and directly over your nail when surveying. So when you survey, we use like 6-inch nails. They got a little hole in the middle of them so you can get directly on top of them, and so it's more accurate. And then when you go to another spot, first you have to shoot the distance and you have to put another nail down, shoot the distance to the prism, and then you have to switch positions, back sight, just to make sure that nothing's messed up. It just makes it more accurate. If you do not accurately set up your instrument, your survey can go from being off by a few tenths of an inch to feet. When you set up the instrument, you want to be able to make as many shots as you can without moving the instrument. The more setups you have, the greater chance of having an error. There's a lot of different types of surveys. One of the most common surveys is a boundary survey. Just maps out the perimeter, and maps out the perimeter and makes a definite boundary as to where the lines are. So a surveyor will go out, he'll read the plat, and he'll get somewhat close to where he believes that the corners are, and then he'll start shooting the corners and stake them out and mark them as he goes. You can do a topographic survey. On a topographic survey, the surveyor marks all structures and elevation change on the land. You take shots on everything that you can, pretty much, and it just takes a long time. But once it's completed, you get into the office, someone on the computer, they make you a map, and they show you, just a topographic map of the land. Site layout surveys. Before a building is constructed, a surveyor can stake out a building. They can mark the corners. So they shoot the corners, stake it out, shows where the house is going to be. Then from that, they usually pull a tape, usually 5 or 10 feet, and mark out those corners again, so you have a boundary of where you can't build past. Also, they can take the level of where the ground is supposed to be the foundation is supposed to be, and they can mark out how much dirt needs to be added or how much needs to be filled for the grade. After a building is built, you do an as-built survey, which is where the surveyor comes out, takes shots of every corner of the house, pretty much everything at the house. So air conditioner units, electrical boxes, fences, anything. And they go back and make a 3D map of that. So the landowner has a map, everybody has a map. Surveying and geotechnical engineering. In geotechnical engineering, total stations are used to monitor the progress of building. They're also used to detect any structural changes throughout the project. They help detect weakness in dams, tunnels, caves, and mines. Most of the total stations that are used for these are set up and monitored remotely. They're robotic total stations. They detect land conditions and structural changes. They're also used to detect natural disasters such as sinkholes, landslides, avalanches, rock slides, anything. In conclusion, total stations are very complex instruments. They've changed the game in surveying. The most important part of surveying is how fast and accurate they are. Consistency is the most important part of surveying, keeping your setups and everything consistent. You do the same thing the same way. If you're off the same way. If you switch it up and just do a bunch of different things, just creates a lot of different movements on your instrument, and it just can cause you to be very inaccurate. Thank you very much. What? What?
The Jets kickers missed 3 field goals. Like,
all right, you do this shit right, so I don't fuck it up. Holy shit!
just let me call. You do it, Bobby.
You do it, Bobby. I ended it. Okay.
Your shit, Bobby.
I stopped the share.
Yeah.
Escape. I paused the share. How do you end the call? Trying to escape. It's not letting me escape. More.
You ended the recording.
Yep. End.
Yeah.